Welcome to a How I Made Them description of the animatronics singing jumbo-sized Christmas balls that we have in our Christmas light display. The inspiration came from a project by Brian Lightman way back in 2014, when he described his brilliant computer-animated singing regular-sized Christmas balls hanging on a tree. I pondered the possibility of supersizing the Christmas balls and then making them sing. Let's have a quick look at Brian's brilliant piece of work to see where my inspiration came from, before we get into my project.
Hey, jingle bells, jingle all the way. Ba-ba. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle all the way. Ba-ba. Oh, what fun it is to ride in a one-horse open sleigh.
Well, where do we start? The big problem initially was trying to find something large enough to use for the balls. I searched for 3 months to find something big enough, and eventually discovered some 620mm or 25-inch diameter PVC beach balls in a local sports shop. The original plan was to use PVA glue and paper towel papier-mâché over the ball to create the ornament. Investigation proved that this would not be strong enough. A covering of cheesecloth over the ball as the form, soaked in polyester resin, then covered by polyester resin-soaked fiberglass cloth would be very much better. The beach ball was pumped up very tight, then cheesecloth stocking it was stretched over it and soaked in polyester resin. The first attempt was a disaster, as the polyester resin attacked the PVC ball before it hardened and collapsed it completely on the inside. After much head scratching, the ball was covered with PVA soaked paper towels and allowed to dry, providing an impervious layer between the PVC and the polyester resin. Cheesecloth stocking it was then stretched over it, tied off top and bottom, and a piece of heavy string tied around the top to hang it from. The cheesecloth was then soaked in polyester resin and allowed to dry. Several coats of fiberglass styrene cloth were then applied over the ball in small pieces, all overlapped. Initially coarse cloth, then fine on top to create the final form, allowing the layers to dry in between coats. The trick to getting the resin to harden quickly was to get the workshop temperature over 20 degrees C, or 68 to 70 degrees Fahrenheit, in our midwinter. The top and bottom tie-off ends were cut off, ground down and glassed over to ensure their strength. Once the covering was totally hard and dry, much hand sanding was required to remove any lumps and bumps. Here the eye positions have been marked up and the mouth cut marked up. Using an angle grinder with a very thin cut-off blade, the top of the egg was cut off. This is the top of the head. And here we have the mouth or bottom section. Running in parallel with the fiberglass work was a requirement for some eye mechanisms. Thankfully Mr. Google found some great ideas. Let's see Marshall Turl's brilliant setup. The eyes here are only 25mm in diameter. Much searching on AliExpress found some 100mm or 4-inch diameter clear Christmas balls for small change. They'd make brilliant eyes. A clearance shop had some dummy surveillance cameras, the windows of which would make great eyelids when repurposed and cut in half. The blue mini servos were sourced from Thailand. The small black one from Hong Kong. That small black one is a very high-speed servo, especially for the eyelids. The industrial plastic frame came from some damaged equipment from my work at the time, plus some 6mm or 1/4 inch diameter threaded rod. Radio control ball ends and universals from a model store, plus a few bicycle spokes and miscellaneous bits and pieces from my workshop make up the kit set. Here is the initial assembly viewed from the rear. And now the initial assembly again from the front. Here we have the eyes on viewed from the front. To mount the eyes, a length of 1/8 inch brass rod with a washer soldered on one end has been epoxied into the internal centre of the eyeball, located centrally by a jig. Now a rear view with the eyes on. The eyeball is mounted on a universal to allow movement in all directions. To complete an eye we needed some irises, so I downloaded some and printed them as photos. Here are the blue ones. Here the eyeballs have been painted white and the blue irises attached. Here we've got some brown irises ex-Google, also downloaded and printed as photos. Now we've got a front view of the whole assembly complete with the eyelids shut. Now we've got a back view with the eyelids shut. A front view, all assembled and the eyelids are open. And now a rear view, all assembled with the eyelids open. Here an internal view of an eye, showing the universal joint and the brass drive attachments. Now another internal view of an eye, with the eye slightly rotated to the left. To test and set up the eye mechanism required an 8-channel manual controller. It is built in a utility project box and has 8 calibrated 1 to 2 millisecond pulse width outputs at 20 millisecond frame rate. Here the servo output sockets and a 5-volt DC input. On the other end is a 25-pin D-range socket for the 8-channel servo pulse outputs to the Christmas ball for testing the animatronics. Power in and cable to the eye mechanism. Now let's see them in operation. Looking left, then right. Oops, a grubby control pot. Look up, then down. Left eyelid. Right eyelid. Both eyelids. Eyes searching. Rear view, relatively wide shot for the eyelid operation. Now with the eyes searching. Now we have a rear view of the eyelid in operation. Now the eyes searching. Looking left, then right. Look up, then down. Well, now back to the fiberglass. Heavy sanding of the inside to remove the PVA and paper towel lining. Some heavy wire glassed in at the bottom edge for strength, and the eye cutouts are made. Now a small disc of marine pliers glassed in at the top for bearing support. Here we have a large disc of marine ply glassed in for the bearings and internal equipment mounting. Now the eye mechanism mounts are in. The eye sockets are now formed and the eyebrow bearings in. Looking at the mouth, we have the centre support and the hinge mount on it. Another view of the mouth. Okay, now the expensive bit, the spray paint. About 8 or 10 cans of each. Here the gold head's been painted. Now the gold mouth is painted. And the gold cap. It's a repurposed pot plant pot. Now the gold eyelids are painted. Here we have the silver head, it's painted. And the silver mouth. And the silver cap. And silver eyelids painted. Here we have the cap mounting lip and the cable inlet at the top of the ball, plus the hanging rod. Now, just to make it look good, we put the cap on as well. Well, now fully assembled, we've got the gold ornament with some initial still frame expressions. Here, the silver ornament, some initial still frame expressions. Here we've got a close-up of the silver eyelid with the eyelashes from some fringing. Now a close-up of a gold eyelid with its eyelashes made from fringing. Here we have an eyebrow made from a dollar store comb mounted on 1/8 inch brass rod, trimmed and shaped by my wife. Here we have the eyebrow from the other ornament, also from a dollar store comb mounted on 1/8 brass rod, trimmed and shaped by my wife as well. One ornament has a red mouth drawn by my wife, made from foam board and painted and stuck on with Velcro dots. The other ornament is a pink mouth drawn by my wife, also made from foam board and painted and Velcro dotted on as well. Here are the servos again. The large one on the left operates the mouth. It's a 32 kilogram per centimetre beast and quite fast as well. This is a very awkward view of the jumbo mouth servo mounting inside the ornament. Another rather indistinct photo of the mouth servo attachment and its helper spring. Another awkward view of the slow rotate servo mounting way up inside the ornament. The ornaments, when on display, are supported by a satellite dish mount on a backing board, which is F-clamped to a veranda rafter. The rotating mechanism is in a sandwich box. Here we have the gearbox that rotates the ornaments 180 degrees when they're required to display, and also their old school micro-switch end stops. Looking under the box, we see the attachment hook. Another view of that assembly from a distance. Now standing on its end. Now with the lid on. Now, as set up for display, the silver ball is parked and ready. Top lights are visible above. They rotate 180 degrees when performing, and then park back again. Here's a closer look at its mounting. The gold ball parked and ready. Top lights are also visible above. And a closer look at its mounting. Controlling the ornaments is a 32-channel Renard board in the left-hand box, with Chris Maloney's brilliant Ren servo software loaded into the picks. The pick outputs are buffered by optocouplers with transistor outputs in the right-hand box. These drive a line driver IC to get the signal up the long cable to the ornament. A problem I encountered was that the Renard controller still sends out channel data when the ornaments are not in use. That signal was way outside the servo's precision range and had to be eliminated. This required having the signal to the ornament gated off a few milliseconds before the end of the sequence, thus ensuring the servos were in a known parked position at rest. The gating signal was acquired from the Renard channel controlling the ornament floodlights. To illuminate the ornaments at night, I acquired a 1000 watt slide projector, modified to automatically turn the fan off 1 minute after it had run. It is fitted into a storage bin box, weatherproofed and ventilated. To light both ornaments from the one projector, I had a mask laser cut with 2 circular holes in it, then fitted the mask diagonally into a slide holder and rotated the mount 45 degrees. That way, 2 circles of light illuminate the ornaments and nothing else. Here we have a few expressions gathered from a daylight photo shoot. The ornaments were sequenced individually by hand in Vixen 2.1. The mouth movements were captured via Audacity using Chris Maloney's conversion software, which is now all converted and played out through X-Lights' X-Schedule. Well, that is about all, apart from acknowledging the brilliant writing of Brian and Terri Kinder, who created the song that has made these ornaments world famous in Nelson. So, let's finish this how-to with the ornaments singing Them Blinking Lights by Brian and Terri Kinder.
Why don't you take these blinking Christmas lights back to the blinking Christmas lights store?
I can't take these blinking Christmas lights back to blinking Christmas light store.